Okay, so welcome back to C# application development. This is going to be the code along video for code generation, and we're also going to kind of look at the code that you'll be using for the last assignment in the course. So just to kind of reiterate, we had the third assignment in the course was an optional WPF calculator app. If you did not do that assignment, you'll have to do this assignment for full credit in the class. If you did do that assignment, you don't necessarily have to do this assignment, but it is a good thing to do because this is certainly something that's going to become more prevalent in job interviews, I think, because of how powerful it is, and you're going to see that in just a second. So this is, again, one half of the optional assignments. You can do this one or the third assignment. You have to do one of them before next Friday. So what you're seeing on my screen is a JSON array. And so this JSON array is very, very, very primitive. It has a name attribute for each of these blobs. That attribute essentially tells you what the entity is. So this top one is a bill, then we have a payment, and then we have a goal. So this application for data management would be something like keeping track of your bills and when you paid them, and if you have savings goals, for example. So inside of each of these blobs, aside from a name, you have a whole bunch of properties, and those properties are each mapped to their respective data type. So here I have an ID that's of type int, I have a payee that's a string, I have an amount that's a numeric value, so on and so forth. And so this blob of information is exactly what you would expect a WYSIWYG designer to create after the business analyst or whatever did their drag and drop work and created the sort of entities around your services. So I could go in here and I could create a brand new entity named something completely different. And as long as it kept this general shape, it would generate all of the code that we're about to look at. So I could modify the properties to add a new property. I could do completely different names, whatever I wanted to do, and that would update my models and my EC. So in this example, we're not going to go all the way up to the API controller. We're not going to go to the client-side code, but it's very easy to sort of think about how you would do those things, simply using the same patterns that we're going to talk about in the first two layers. So another thing that you kind of need to think about is this numeric type. So numeric type is not really necessarily a thing in C#. What this means is I want to use some sort of decimal value. So what you're ultimately going to do in the first part of the assignment is use conditional statements to impose the correct strong type on these things. So string is pretty easy, int is pretty easy, bool is pretty easy, but numeric, you can do this as a decimal or you could do this as a float. It doesn't actually really matter. What this is serving to show is you don't necessarily even have to expose in the tools the idea of a float or the idea of a decimal or a double or whatever. You could have a very easy type system, and that type system would infer strong types during translation, which is what we're looking at right now. So this is sort of where everything starts, is this giant JSON blob. It is stored in a directory called data, and this just gives me basically a markup for my models. What do my models look like? Well, each of the entries in this JSON array is a model itself. Okay, so the rest of everything is a .tt file. And so we're going to talk a little bit about how the application is actually structured now. So this whole project is just a C# console application project. It isn't a special text template project. It isn't a web project. You could use this in a web project. You could use it in whatever project you want, but .tt files are basically their own thing entirely. So they'll work in WPF apps, they'll work in console apps, they'll work in any kind of application you could imagine. For simplicity, we're just using a console application right now. In terms of NuGet, in order to make our version kind of work, we need two main things. We need ASP web pages, and we need newtonsoft.json. These other two things just kind of come along for the ride after you install these two things. This is a little bit of a cheat, the way that we're going to write the code. This is not the only way that you can do text translation, but this is kind of the safest way that I figured out to do it and kind of have a lot of control over what you're actually transforming. So when you get the solution off of Canvas, if you open it, you should be able to go to NuGet Package Manager, and you should have an option in here for restoring packages, or you could come in here and actually just make sure that this guy and this guy are installed, and as long as they are, then you should be fine. Okay, so this is a console application. In terms of NuGet, you really just need newtonsoft.json, you need ASP web pages, and the rest of everything, it starts with the driver.tt file, and we'll start with that thing, and that'll explain what these other two things are doing. So if you see this, the main problem with text transformation files is that they have no IntelliSense, and they have no sort of nice color coding. It's sort of terse to work in, and it can get very, very confusing. So to make that as easy as possible, the driver file, what it is going to do is as much sort of business logic up front as possible, and then it is going to pass off pieces of data as small as possible to both a model template, which is going to build models, and then an EC template, which is going to build the EC based on those models. And so I'm going to walk you through 99.9% of the creation of the models file. I'm going to introduce what you should do in the EC template file, and then finishing the model file and implementing the EC file is going to be the assignment for the end of the class. So what the heck is this even doing? So at the top here, what I have is I have a sort of weird self-aware line of code here that allows this file, driver.tt, to understand where it itself is. So what template directory is doing is it's using the path.get directory name that's part of system.io, and this .host is actually a singleton from last week, where we can get the template file itself, relative path driver.tt, and get directory name gets the name of the directory that file exists in. So template directory will be set to root folder / transformation. Then what we're doing is we are going to this file right here, which is my current location, which is here in transformation, up one, so ... goes up one directory, and then to data, then to models.json. So what this line is doing is it's actually using file.readAllText. We very briefly covered this in a previous video, but this is in system.io, and what this is going to do is it's going to slurp all of the contents of this JSON file into a string called model.json. Then we're going to do the exact same thing, except instead of pulling the JSON into a string, we're actually going to pull the whole template file for the model template into a string. And so this right here is going to be the JSON. This right here is going to be a text template file that looks very much like this one. And we're going to do the same thing with the EC. So the EC template is also going to be just another text template file, but it's going to be the contents of those files. So here we're using readAllText to get the actual text out of each of these files. Okay, so then what are we going to do? Well, what we want to do is we want to take the data that's in models.json, and we want to arrange this data in a data structure that's very, very easy to iterate over, and that's very, very easy to modify or kind of reconfigure into a shape that we can use to build models. So how we're going to do that is we're going to build a data structure that is a dictionary of type string, dictionary, string, string. And so this, at first blush, seems absolutely absurd, but let's think about what this is actually going to do. So the first string, this thing is actually going to give you the name of what the model is. Inside of each of those entries, so bill, goal, or payment, so there are going to be 3 entries in here. Bill will have another dictionary, and that dictionary will be a series of pairs of properties, and it will be property name and then property data type. Property name, property data type. The keys are the names, because you can't have the same property with the same name on multiple properties. The data type is the value, because you could have 50 int properties, you could have 50 date time and properties, whatever. So what we're going to try to do is we're going to take this JSON and we're going to use the jarray.parse method that we used previously in the GitHub WPF example, and we're going to parse this JSON that we read out of the models.json file into an array, then iterate through all of the children, and then iterate through all of the properties of the children, and build entries in this model's definition dictionary. And so how do we do that? The first thing we do is want to make sure that we actually are reading JSON that makes sense. So as long as we have something in model JSON, proceed. If we don't have anything in model JSON, don't even try, because we can't really parse an empty file or an empty string into an array. So then we're going to actually do the parsing. And this models is going to be kind of the list of all of the J objects in the array. So models is going to have 3 entries. It's going to be bill there, it's going to be payment to there, and it's going to be goal to there. Inside of models, what we can do is we can look at all of the children inside of the list. We can cast them to JObject. So what this does is this actually gives us a JObject that is exactly this blob. And inside of each of those JObjects, you're going to have access to properties, and each of those properties is going to be one of these things. So here, what we're doing is we're saying, okay, if we see a property, so if we have a JObject at all, we expect for our models to have names. So this is the first part where if you don't have a model that has a name attribute, suddenly this thing will crash. So in your tooling that builds this, you would have to enforce the fact that you have to have a name, or the transformation is not going to know how to do its work. Here we're setting a model name variable to the name attribute, and the reason we're doing that is so that we can actually put the name into the list as the name of the entity, and then we're going to use that to actually generate individual files. So we're going to know that there are 3 entities, and we're going to have 3 model files. We're going to have 3 different ECs, so on and so forth. So that's this part. The next part is actually creating a dictionary of string, and then iterating through all of the properties, and then adding each of those properties to that list. And so if we look at this, what's going to happen is the first property is going to be the name, the second property is going to be the ID, third property is going to be payee, so on and so forth. The reason why we want to keep the name property in here is because we're not going to pass the entire dictionary string to each of the files. We're only going to pass the value to each file to minimize how much data we're passing around. So if we put this name at the top of this dictionary, it will help us. If we put it in its own place on the outside file, the driver file, it lets us very quickly access it to build individual files. So when we get down to here, new stuff starts happening. So all of this is stuff that we've already covered in the class. So we're essentially just reading a file. We are performing some conditional checks. We're doing a for each loop, and we're using the jarray.parse method that we've previously used in the WPF example where we were actually calling out to the GitHub API. So at this point, things get significantly weirder. So this engine class, this is the thing that's going to actually perform text transformation. So this is the actual text transformation engine. We're just going to create a new one of these things. We can use it over and over and over again. So we're going to initialize it outside of this for each loop. So we're not doing it over and over, or doing that initialization over and over. And what we're going to do is we're going to iterate over all of these model definitions. So for each entry in our data structure, we're going to first build models and then build the EC, and then go to the next model, build the model, build the EC, then go to the next model, build the model, build the EC, and so on and so forth for all of the models. So because this is a for each loop and because model definitions has been dynamically generated, that means that you could come in here and you could add 74 different models, and this would always just create 74 files over here that is implement whatever properties you had in your JSON. If you wanted to create client-side code, or if you wanted to create API controllers, instead of just doing the model and then the EC, you would do the model, then the EC, then the API, then whatever client-side code you wanted. You could do all sorts of stuff. The question, though, is why do I have to do it in that order? If you remember, sort of order of operations for making a service call is I start on the client side, I send a request over to the web API sends a request to the EC sends a request using models to persistence, and then we're done. So if we don't build models first, what's going to happen is we're going to build an EC that references a model that doesn't exist yet. If I build the web API first, I'm going to call an EC that doesn't exist yet. So we have to build things in the reverse order that we call them in. And so that's the number one thing to think about and to remember about this whole process. Is if you do things out of order, it's kind of okay, but the automatic build will not work. You're going to have to manually build after you generate everything to make sure that your code actually has all of the dependencies that it needs when it's built. So at a high level, what this is doing is it's going to build models, then build the EC, and then iterate through and build model, then EC, model, then EC. So how are we going to actually do that? We are going to essentially cheat and call this thing called call-to-context.setData. So in a traditional semester, I have this whole spiel that I do on a whiteboard with like boxes and all sorts of stuff, and it's really hard to translate to a video. So I'm gonna explain it, and I think that it will probably make some sense. If you look at Task Manager in your on your computer, each of these tasks. So you look, I'm running OneNote and Outlook and PowerPoint and all sorts of stuff. Each of these things has what's called an app domain. That app domain has some memory inside of it that can be accessed through what is called an RPC, or remote procedure call. And there are 100 million ways of doing this. And essentially what I'm talking about is sharing data between processes or process boundaries or app data, domains, or whatever abstraction you want to talk about. What we have here is a bunch of files: model.template, ec.template, you could have webcontroller.tt, you have all sorts of stuff. And these template files have no idea that each other exist. They sort of exist outside of a lot of the sort of structure or the context that we've been using in other applications that we've been developing, or other projects. So what we're going to do is we're going to use call context that's going to serve as essentially a big old memory storage box. And so call context itself has a set data and a get data method. The set data is going to give a key and a value to the call context big storage container. And then when you call get data, you will actually get this key as an object back out. And so here, what we're doing is we're iterating through all of the model definitions, and we are sticking the current iteration of that model definition into call context with the name current model. So if you think about iterating through this, in the first iteration, the current model will be bill. In the second iteration, the current model will be payment. In the third iteration, the current model will be goal, and then you're done. So what this is doing is it is setting up a kind of third-party intermediary where we can actually store data that can be accessed by other TT files. So here, what we're doing is we are actually using the engine to process a specific template using the current host. So this host basically means that we are coming from the same sort of text transformation context. Models template is the literal contents of the TT file that implements models. So remember, models template, if we do a search, we set it up here by doing read all text on the model template TT. And we'll go into this in just a second. So write is a method that will write to the text file that is underneath the TT file. And so if you go to Solution Explorer over here, and my head is actually in the way, I'll move myself. If you go to the text file underneath each of these driver.tt files or the ectemplate.tt file, this write method allows you to write a string to that file without breaking your component. So the two ways of doing this is to break your component here. So put that, and you could do that, and you could leave write out and just print model out. Sometimes having a bunch of nested components is really hard to debug, so write just allows you to do the same thing without nesting them. The next thing that we're going to do is we're going to figure out a path that we want to stick the contents of this transformation. So process template, what it's going to do is it's going to take a look at our EC template, and it's actually going to perform the transformation, which we're going to talk about when we look at this file. And then the transformed file, the text in that file will come out as modeled out. So now we are going to use path.combine that takes a directory path and then a file name, and we're going to create a new file called model out path, and we're going to write the text that we got from the process template method into that file path. And that's where each of these comes from. So bill_gen, goal_gen, payment_gen. Word of caution. Just because you are writing this thing to disk does not mean that it will be included in the solution. So if you run this file for the first time on your own and you have not already added bill_gen, goal_gen, and payment_gen.cs to your solution, what you'll have to do is right-click on transformation or right-click on whatever directory you want, click on existing item, and then select them as files to add. So again, what this is doing is writing them to disk. That does not automatically update your solution file to actually show them in Solution Explorer. They will be on disk, but you have to manually right-click and add them. You only have to do that once. So if you add a new model, you will have a new model file on disk. The first time you generate it, you will have to manually add it to your solution. But outside of that, it should work indefinitely. You can actually automate that process itself using what are called post-compilation steps, but that's beyond the scope of what we're trying to do right now. So this thing is the driver. The reason I called it the driver is you can kind of think of it as the main method of the whole process. And it is going to need to call models to generate models. And then when you perform the assignment, you're going to have to do the exact same thing to call your EC template to generate the template, or the ECs. So I'm going to put here, next, we should build the ECs. Your code here. So this will be part of the assignment right here. Okay, so model template. So model template gets called by driver TT right here. And what we're doing is we are passing this whole string, all of this text, into driver TT, which then uses it to process the template to get the model, the text back out. So this is the untransformed TT file. And in here, we have a little bit of pre-processing logic. And then we have some essentially print statements that build much of a class definition in the new file that you're creating. So let's talk about the pre-processing first, and then we'll talk about what we're actually printing down here. So we are first pulling the current model as a dictionary string from call context. So remember, in the driver.tt file, we put data into call context under the name current model. We had all of those entries as dictionary of string. Again, this is the name of the property. This is the type of the property. Let's say that we don't get a return from this. What we would do is we would want to return just a blank list. And what that will do is it will keep it from crashing. We just won't do anything down here. So what do we need to do now? What we need to do is we need to set up some property definitions as this new dictionary. And so doing this part is going to let us do kind of the separation of the first entry, which is the name entry, and then all other entries, which are actually properties. There are 5,000 different ways you could do this. This is probably the most kind of naive way. I was just kind of going for readability more than anything. So literally what this thing is doing is, if I have a model definition, so if I pulled something out of current.model, if this whole thing didn't throw an exception, for example, I will take the name as the property that is called name, and then for everything else, as long as the key is not name, I'm going to add it to a new list called property definitions as the key and the value. And so remember, this thing is a list of these, but we have this top thing that's there. This is not actually a property on the model. This is the name of the model. These are all properties of the model. These are the things that are in prompt definitions. This has been excised into a name. So the code component here stops. So this is all pre-processing. Now we actually start generating code. And so here we have the very first line of most classes, giving it a namespace. And so I'm just calling this namespace code generation example.transformation because it is in the code generation example.transformation folder. And this curly brace goes with this curly brace. So this whole thing wraps a namespace. And if you look at our GitHub WPF for sort of a example, that's this part. So the namespace and then the closing brace. So then what we're doing is we are setting up the actual class. So we have the literal string public space class. And then we're also going to prescribe the model name. And so again, the model name comes from the name attribute on the dictionary here. This is what's going to build public class bill, or public class payment, or public class goal. Then we're going to start another code block. And in this code block, we're going to start a for each loop. So in this for each loop, what we're doing is we are iterating over all of the items in property definitions, and we're going to print a property definition for a class that uses that name. And so this open brace goes with this open brace. Notice that this is a C# block and this is a C# block. This closing brace goes with this, which is the C# that you're generating. So this closes the class block, and this closes the for each block. So what is going to happen is the driver is going to run through. It's going to call the models.template file. It's going to slurp all of this text into this process template call. Then it is going to load that. We're going to take each of the J objects. So in here, we're going to call this models template for bill, and then for payment, and then for goal. And each of those, it is going to first pull the name out, it is going to name the class that name, then it is going to look at the list of properties, and then it is going to iterate over those properties and give you public properties with a default getter and setter for each of them. Now, there is a glaring missing thing here, and that is the type. So the very first thing that you need to figure out is figure out how to use if-else statements to get the correct strong type of each of these properties. So you're going to use the same syntax that I used for the for each loop for if statements. And so it's basically going to become public, and then you're going to have an if. If the item dot value is numeric, print decimal. Else, if it's int, print int. Else, if it's string, print string, so on and so forth. That will let you handle any data type that you want in terms of strong data types for C#. And then once you do that, you'll be able to generate this whole class. And so I'm going to show you what it looks like right now. So driver TT. If I go to build and then transform all T4 templates, it's going to give me a whole bunch of errors. And the reason is because if you look at build gen, for example, this is being generated. So I have a namespace that's correct. I have a class that's correct. What I don't have is a type for each of these public properties. And so that public, that type is what we just added as a to-do for the assignment. And once you get that type done, this will no longer have compilation errors, and then you will no longer have these errors in here. So kind of zoom out for a moment, and we're going to talk about kind of why we use a driver file, things that can go wrong that will seem way worse than they are. So once you go to build transform all T4 templates, what happens is the T4 templates are transformed in the order that they were added to the solution. Which, if you are like me, I very rarely do things sequentially by default. I usually am all over the frickin' place, as is evidenced by many of these videos. So what you will want to do is use something like a driver file in order to force the order in which you're actually transforming things. Let's say that the model template file gets transformed prior to the driver.tt file. If that happens, you will not have set the call context data. So when you go to the model template, there will be nothing to pull. And so you won't actually get any content in model template.txt. And so there will be nothing to put into build gen, goal gen, or payment gen. So you could see things like null object references. You could see things like all sorts of stuff. You don't actually care about that if you have a driver TT file, because most of the time that error is going to get thrown, and then the driver.tt file is going to fix it, whatever it is. That isn't true 99.999% of the time. Of course, there are situations that arise when problems are actually real. And in that case, what you can do is you can right-click and transform each of these things in order. So if you want to do that, You can debug the T4 template and attach debugging breakpoints. That's may or may not be helpful depending on how you have your template set up. But for whatever reason, transforming the single TT file is called run custom tool. No idea why, but if you hit run custom tool, that is what actually generates everything. And so I've actually regenerated bill gen and goal gen and payment gen. So one thing that's really, really important to note is that many times when firms want to use code generation, they generate a comment at the top of this, something like, hey, if you change this and the code is regenerated, your code is on. To keep people from saying, oh man, I see where the bug is, and then they come in and they fix the bug in this code, and then they save it, and then somebody comes over and right-click run custom tool, and now suddenly your stuff is gone. That is very, very common and extremely frustrating. So the way that you fix bugs in these things is you have to actually go to the driver.tt file or the model.tt file and fix the generator and not the generated code. Because otherwise, when the code gets regenerated, the bug is going to come back time and time and time again. Okay, so what do you actually have to do in the assignment? It's two things. One, you have to add types for each of these public properties. So this part should be pretty easy. All you have to do is use this syntax with if or else statements to print the appropriate word here. So it will need to be int for int or string for string. You could use whatever numeric type you want. Double, decimal, it doesn't actually really matter. It's entirely fine. The other thing that you need to do in driver.tt is you will have to do this same process to create an EC file for each of these things. So the EC file is going to have two methods, and I'll put that in the write-up. One of them will be get by ID, and the other one will be get. So you just return the whole list. You'll basically just have to implement that in this EC template right here. So you will come in here and you will do largely this exact thing right here. But in this case, you won't necessarily need most of the information that you need here for properties, because the properties really are inside of the model. They're encapsulated inside of the model. For the EC, really primarily all you need is the name of the entity. So the EC is much, much easier than generating the model. And so you'll basically just have to fill in these blanks with similar code that pre-processes and gets your data structure ready using current model, and then prints the EC that is in the write-up, and that's it. And I'll actually give you the full EC implementation so that you don't have to do any guessing or anything. Literally, all you have to do is match my code. So that is really it. This is way harder than it seems. If you spend about an hour with the code after watching this video, if you watch this video a couple of different times and you kind of step through the process, you will pretty quickly pick up on it. And again, all you have to do is replace this part with the EC part, and you have to replace this with an actual piece of code that gives you the correct type here. And again, it doesn't matter what you use for the numeric type, either one will work. So you have a little bit over a week to do it. I think that it's probably a day job in general. So if you have questions, comments, concerns, please let me know. I'm happy to have a meeting or a screen share and sort of walk you through some of it. and have fun with it. I realize that the last week of classes is not when you have the most fun, but this is a really powerful tool, and I think that it's going to catch on, or it's already catching on, but I think it's going to be very, very useful in the future with all of these kind of very tedious practices and processes that software companies have to go through. So thanks for watching the video, and I will see you in the next one, and good luck with the assignment.